Okay, hi guys. So in this lecture, we'll be continuing on our discussion of intramolecular aldol. Okay, so let's just write some notes on the same. So let's get started. So notes. First one is that in intramolecular aldol, major product is decided by the order of ring formation. That is, six-member ring will be given higher priority than five. Then it would be given higher priority than seven. Okay, so in intramolecular aldol. Major product is decided by order of ring formation. That is 6 is given higher priority than 5, which is given higher priority than 7 member rings. Okay, second point is that in case of two same sized rings, major product is decided by the reactivity. Okay, that is aldehyde, as aldehyde is more reactive than ketone, then obviously the product would be decided by having aldehyde as the electrophile. Okay, so or aldehydic group as the electrophile. In case of two same sized rings, major product is decided by reactivity. That is, aldehyde would be given more priority than ketone, or as aldehyde is more reactive than ketone. Okay, so now let's do some questions in which you have to identify the major products. So we have something like this compound. Again, we are providing basic medium and we are heating it. So what will happen? Let's count number of, if there is any six member ring formation, 1 2 3 4 5 6. Yes, it is there. When this CH2 minus will attack on this oxygen, so as a result we'll be getting six member ring here and double bond here, double bond O here, and CH3 here. So this would be the major product. Okay, I forgot to write the heading. Identify products. Okay, let's start off with the second example. We have this example wherein we are reacting this compound again in basic medium and in providing some heat. So any six member ring formation is there. When this carbon actually reacts on this 1 2 3 4 5 member ring is only there. Okay, when oxygen, or rather let's forget it, five member ring is there when CH2 minus will react on aldehydic group. Okay, and obviously this is the last possibility and the only possibility. Why? Because there cannot be any nucleophile on the aldehyde group which can act on the C double bond O, because there is no alpha hydrogen attached to the C double bond O group, as this carbon atom is having two CH3 groups. Okay, so this would be the only option left for us. Obviously this is also an option, but obviously we will not see it because it will form only three member ring. So we'll go with the five member ring, wherein this will attack on rather this oxygen atom. So as a result we'll be getting something like five member ring first. Okay, double bond O here, CS2 here, CSC here, 2 methyl groups here, and this would be the product. Okay. What about this example? We have double bond O here, and we have CH2, CH2, C double bond O, and CH3 here. We are reacting it in basic medium. Again, we are heating it. So what would the major product formed? So both are keto groups. Okay. So let's see. If this CH2 minus will attack on this carbon atom, we will get 1, 2, 3, 4, 5, 6 member ring. So we'll be attacking this CH2 minus on this oxygen atom. So as a result, we'll be getting something like again a 6 member ring. Okay, and 1, 2, 3, 4. So there will be a double bond here. Okay, and double bond O at the adjacent carbon. Okay, let's look at fourth example where we have this compound. Okay, we are first passing it in O3 with zinc presence. So we'll get, let's say, compound A, which on passing with KOH and heating it, we get product B. Okay, so we have to identify the unknowns. Okay, what will product A? We have done so much practice on this. Product A would be something like double bond O here and double bond O here. This will be product A. Product B would be, both are aldehyde group. Okay, if you can have any of the CH2 minus attacking on this oxygen atom, so we will have 1, 2, 3, 4, 5, 6 member ring. Okay, first draw a 6 member ring, then this carbon atom will attack on this oxygen atom. So one will be oxygen atom, rather a double bond, not an oxygen atom. So it would be a rather 5 member ring, I suppose. Yeah, I drew it wrong. This would be a 5 member ring. Why? Because 1, 2, 3, 4, 5. 5 here. We have a double bond with this carbon atom and this carbon atom. Double bond here. And then aldehyde group attached to the first carbon. Okay. Let's see another example. We have something like this. And then we are reacting with first ozone. We get product A. Then we are reacting it with KOH to get product B. We have to identify the unknowns. So what will happen in O3 is we'll be getting something like this. Okay, double bond O here and double bond O here. Okay, next what will happen is when we are reacting with KOH, suppose this, although the means it doesn't matter, the product is, the compound is anyway symmetrical. So let's attack this as a nucleophile on this oxygen atom. So as a result, we will be getting 1, 2, 3, 4, 5 member ring. Okay, and if we react it from this carbon atom to this oxygen atom, we will be getting 1, 2, 3, 4, 5, 6, 7 member ring. Okay, so 6 member ring is more stable than 5 member ring, and 5 member ring is more stable than 7 member ring. So as a result, we would be attacking this carbon atom onto this oxygen atom. Okay, so as a result, we will be getting a 5 member ring first. Okay, where we have a double bond between this carbon atom and this carbon atom. Okay, and then we would be having something like this carbon atom ring actually is going outside. Okay, 1, 2, 3, 4, 5. 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We are up to this carbon atom, and then what we will be having is 6 and 7. Okay, so 6 and 7. Okay, and a double bond here. So this would be the final compound. Okay, so 1, 2, 3, 4, 5, 6, 7 member ring having the double bond O atom, and this is a 7 member ring having the double bond O atom, and we have 5-member ring which is having a double bond alkene group. Okay, let's look at this example wherein we have something like this OH here, and then we are passing it in let's say acidic medium, and then we are heating it, we get product A. Then we are passing it in presence of O3 and zinc, we get product B. And then okay, so just identify products A and B. Okay, so when we are passing H plus, obviously O will attack on H plus, we will get a positive charge here. Then we are also heating it, so elimination reaction will take place in which this hydrogen atom will actually again be out of the compound as H plus, and will get a is there any hydrogen atom attached on this carbon atom? No. So then what will happen to this compound is we have to think through it carefully. So let me just write down the steps as well. So what will happen is, first we will get some positive charge at this carbon atom because of the H2 water molecule released. Okay, and then what will happen is rearrangement will take place. Why? Because this plus is more stable at this carbon position. Why? Due to obvious more plus H reasons. Okay, so we'll get something like this. Now what will happen is there is a alpha hydrogen here. What will happen on heating is it will form a bond here and we'll get something like this. Okay, next what will happen is when we are reacting with, this is the product A, when we are reacting it with, okay, so let me draw the C product as well. When we are having KOH and heating, we get product C. Okay, we have to determine all the products. Okay, so now what will happen is, obviously we have done so many examples of this reaction. Okay, one, two, three, four, five. No, that is not the compound to be formed. So how will the positive charge, when I think we did some mistake over here, when the positive charge is actually arriving at the middle carbon atom, we would have a different compound altogether. We would have something like, when we actually are rearranging, what should we be getting is ring expansion will take place because there is no H plus here, and ring expansion will take place. Okay, yeah, sorry for the bad communication before. There is no hydrogen or any other group attached here. Instead, this carbon atom will form a bond with this positive charge, and then this carbon atom, which is having the CS3 group, will have a positive charge over it. Yeah, so this would be the compound. Now on heating, what will happen is this hydrogen atom would go and would leave the compound and would form a double bond between this carbon atom and the carbon atom having the substituent methyl group. Then what will happen is we are passing it in O3Zn. Then we have seen it so many times that this would be the compound formed. Okay, now next what will happen is, this is obviously a keto group and this is aldehyde group. So obviously aldehyde is as more reactive, so we'll have something like what happens when this CH2 minus attacks on this O, we'll get 1, 2, 3, 4, 5-member ring. Okay, and what happens when this carbon atom attacks on this oxygen atom, we'll get 1, 2, 3, 4, 5, 6, 7-member ring. Hence this would not be taken, this would be taken. This carbon atom would be taken as a nucleophile to attack on this oxygen atom of the aldehyde group. And what happens when aldehyde group actually acts as a nucleophile on the keto group, we'll get 1, 2, 3, 4, 5, again 5-member ring. So 5-member will get 5-member keto ring and 5-member aldehyde ring. Keto ring, I mean C double bond O belonging to the keto group, and aldehyde ring, we mean C double bond O belonging to the aldehyde group. So obviously C double bond O belonging to the keto group would be chosen because in this case nucleophile would be keto group and electrophile would be aldehydic C double bond O. Okay, so this carbon atom would be chosen as a nucleophile. Okay, so after that we get on KOH and heating, we'll be getting something like 5-member ring. First let us draw the 5-member ring. The double bond O and here will be getting a double bond. This oxygen atom would be leaving, and this carbon atom and this carbon atom will be getting a double bond. Then next on this atom we'll be getting something like the keto group is also attached here. So this would be our final product. Okay, let me draw it more clearly. Yeah. Okay, so with this we come to an end of this lecture. In the next lecture we'll be seeing some more examples of this sort, and then we'll be moving on to cyanoaldol. Okay, so till then, good luck and goodbye.